everyone and welcome back to my channel Chem Talk Academy. And yes, today in this video we will be discussing an interesting and important, very important reaction that is called nucleophilic substitution reaction. Okay, so we will discuss about this topic. Okay, so what we are going to cover, first we will understand what is nucleophilic substitution reaction. Okay, then what is the meaning of nucleophile. Okay, this type of reaction is seen in which hydrocarbons. Okay, then next we will see some examples, in general examples, then we will go for its mechanism. Okay, so let's start with the video. Okay, so the first thing that we are going to discuss, that is nucleophilic substitution reaction. Okay, so what is meant by nucleophilic substitution reaction? From the name itself we can identify substitution. Substitution meaning is what? What is the meaning of substitution? Substitution means to substitute in place of other, right? Generally we see in our school, if one teacher is absent, then another teacher is substituted in place of that teacher who is absent. Okay, the same thing happens here as well. What happens? A nucleophile is substituted. Okay, so that's why this reaction name is given, that is nucleophilic substitution reaction. Okay, so to understand, let us to understand this reaction, complete reaction, first we have to understand what is a nucleophile. Okay, so here see, in name itself see, Nu is there. So Nu means what? Nucleus. Okay, our nucleus is what charge? Positive charge. Okay, so this Nu means positive. Okay, philic. What is the meaning of philic? Generally philic, you had seen somewhere hydrophilic. Okay, what is the meaning of philic? Hydrophilic means water loving. Okay, similarly here philic means what? Philic means loving or attraction. Okay, so here attraction. So generally what we can say, nucleophilic means positive attraction, means a species who is attracted towards the positively charged species. Okay, now if let's consider that I am a nucleophile, I am attracted to positively charged species, means what? I will be obviously a negatively charged species. Okay, so similarly here nucleophile is a negatively charged species. Okay, negatively charged species. Okay, so nucleophile is a negatively charged species. How it is denoted? It is denoted as Nu with a negative sign. Nu with a negative sign. Okay, now this type of reaction is generally seen in case of haloalkanes. Okay, now so many things, so many questions will be coming. Ma'am, where this nucleophile we will get? This will attack to what? What type of reaction will occur? What will be the product? Okay, so don't worry. Here one by one, step by step we will discuss. Okay, so the first thing, nucleophilic meaning is what? Nucleo means what? A positively, a species which is attracted towards the positively charged species. Okay, simple, a best example I am giving, that is, consider myself. If I am a nucleophile, means what? I will be having a negative, means extra. Oh yes, we can also say that a species who is sufficient in electron. Okay, a species who is sufficient in electron means a species will be having extra electron so that it can donate. Okay, so nucleophile means a positively attracted species, means itself it will be having a negatively charged with himself. Okay, so it is a negatively charged species and positively attracted. Okay, it is denoted as Nu minus. Okay, a negative charge is shown here. Okay, then this type of reaction we see in generally in case of haloalkanes. Okay, now haloalkanes means what? An alkyl group attached to halides. Okay, so this X means what? Generally we denote X as a halides. Okay, so what this X can be? X can be chlorine, fluorine, bromine and iodine. Okay, so these are what? Halogens. When a halogen is attached to alkyl group, then it is called what? Our haloalkane. Okay, or alkyl halide. Now what is the general reaction that we see here? Okay, so the general reaction will be, see, when an alkyl halide or haloalkane reacts with a nucleophile, what happens here? See carefully. When an alkyl halide reacts with a nucleophile, what happens here? Here one thing we can focus, that is X means what I told here, halogens. Okay. Now X being a highly electronegative in nature, it will always try to pull the shared pair of electron towards itself. So here the shared pair of electrons are pulled towards halogen. So what happened here, halogen will get a partial negative charge and R will get a partial positive charge. Okay. So now as a result what will happen, this will remove. Okay. Now the attack of nucleophile will take place with the positive charge. As I told here itself, nucleophile means what? It is a negatively charged species or electron sufficient species which is always attracted towards the positively charged species. So here X act as a leaving group. Okay, leaving group. Now X will be removed, nucleophile will attack to the positively charged and it will be substituted in place of what? Obviously halogen. Okay, so it will be substituted in place of halogen. So what product we will get? R, N. Okay, and our X will be removed. X will be removed. Hope you are clear. Okay, so then general reaction, what it involves, when an alkyl halide reacts with a nucleophile, what happens? The being halogen is a highly electronegative in nature, it attracts all the shared pair of electron towards itself and gains a partial negative charge, where it also leaves the group, so it is also called a leaving group. Okay, now after acquiring negative charge here, there is a charge difference between them. Now this nucleophile attacks the positively charged species in order to substitute the halogen. Okay, so hope you are clear. Now, how many types of nucleophiles? There are so many types of nucleophile. Mainly we will discuss about two types. One is monodentate nucleophile, another one is ambidentate nucleophile. Okay, so what is first one? Monodentate. See, how you will identify nucleophile? Nucleophile, as I told, it is an electron rich species. Okay, electron sufficient species means obviously there will be a species where either there will be a negatively charge indicated there, or else there will be some extra lone pair of electron. Okay, now those are called whatever nucleophile. Okay, so first variety that we are going to discuss, that is ambidentate. Sorry, not ambidentate, monodentate. Monodentate nucleophile. Okay, so examples of monodentate. See, what is the meaning of mono? See, in every chemistry, physics or biology, the name itself will be having some meaning in it. Okay, so monodentate means what? Mono means single, dentate, donor means that species will be having only one donor site. Okay, example we can take OH minus. Okay, then I minus. Okay, OR minus. Okay, then okay, so these are some examples which are monodentate nucleophile. The next variety that comes, that is ambidentate. Ambidentate nucleophile. Okay, now what is meant by ambidentate nucleophile? Monodentate, as I told, one donor site. Okay, ambidentate means what? Ambidentate will be, there will be two donor site, means in a nucleophile there will be two donor site. Okay, example we can take CN. Okay, so here nitrogen having one lone pair. Okay, so this can act as a donor site. Okay, here carbon, its valence is what? 4. Out of 4, okay, 3 has bond, covalent bond, and there is one more electron that is denoted as negative here. So this also can act as a donor site. So here being cyanide having two donor site, act as a ambident ligand. Sorry, not ligand, ambident nucleophile. Okay, similarly another example, NO2. Okay, NO2 minus. Okay, here also what? If I go for this structure, nitrogen, oxygen, oxygen. Okay, here the extra electron is with this oxygen. So this also acts as a donor site, and nitrogen being having lone pair of electrons, this also acts as a donor site. Okay, so this is the some types of what nucleophile that you can identify. And yes, what is the role of this ambident? Why there are two donor site? Okay, if there is two donor site, then the linkage will be also what? Either from carbon or nitrogen. Okay, so where At what time, at what condition the linkage will be occur, that we will be going to discuss further. Okay, so hope up to now you are clear. Now let's see what are the different examples. Yes, there are so many things related to this as a nucleophilic substitution reaction, but first we will discuss the we will see varieties of example. Okay, so next time when we go for its mechanism, then you will be crystal clear about the complete topic. Okay, so first see some varieties of examples. Means let's see the general we will complete the general reaction by taking different nucleophile and different examples. Okay, so let's go for that. So what type of reaction I have to see? R, X. Let us first write the general equation. By seeing that, we will go for different examples. Okay. So Rx, okay, the electrons are transferred towards what? Highly electronegative element, and this will remove as a leaving group, acquires a partial negative and here partial positive. Now attack of nucleophile will take place. Okay, attack of nucleophile takes place. In result, the nucleophile is substituted in place of halogen. Okay, so the product is R Nu plus X minus. Okay, this is our general reaction. Now let us understand this equation by taking one example. Okay, let the alkyl halide react with NaOH. And don't think that a nucleophile will be given you directly. No, you have to identify which one is the nucleophile. Okay, so here base also here act as a nucleophile. Now tell me which one is the nucleophile. So obviously when NaOH it dissolves, what? It converts to Na plus and OH minus. So we got which one is positive and which one is negative. Now which one will attack to what? This is acting as a nucleophile. So this will attack to what? Our alkyl group. Okay, this acquires a partial negative, this acquires a partial positive. So the attack of nucleophile takes place. Now this X is removed as it is the leaving group. Okay, so now what will be the product? R OH plus NaX. So as before I told, X means it can be anything, any halogen. That can be fluorine, chlorine, bromine and iodine. Clear? Okay. The next one. See, when alkyl halide, when we reacted with a water, H2O. Here also which one is positive, which one is negative? This is positive, this is negative. So what happens? See, this X will be removed. Okay, attack of nucleophile takes place. What will be the product? ROH HX. Okay, so what we are getting here? What the product we are getting? Alcohol. Alcohol. Okay, we are getting the product that is alcohol. Clear? Then the third one. Next example, another nucleophile we will take RX. Okay? Here partial negative, partial positive. So remember why I am writing here partial negative, partial positive. Because halogen being highly electronegative in nature, it always try to pull the same pair of electrons towards itself. Due to electronegativity difference, one will acquire partial positive, another one will acquire partial negative. Clear? Okay, so next electrophile we will take let ROCH3. Okay, so here which one is negative, which one is positive? Who can take? This is negative, this is positive. So attack of nucleophile takes place. Okay, so in result what we get? ROCH3 plus RX. Okay, so what we are getting here? Here we are getting an ether. Okay, here we are getting an ether. Okay, hope you clear. One more example we will take. RX when react with ammonia, NH3. Okay, so let I am writing like this so that you can understand easily. NH3. Now tell me here which will act as a nucleophile, means what will be the negative charge, which part will be negative and which part will be positive? Obviously in between nitrogen and hydrogen, which is highly electronegative in nature, nitrogen. So this will be our negative side and this will be our positive. Okay, so what will be our reaction? Who will attack? NH2. Okay, this is the nucleophile will attack to alkyl group. Okay, now X will be removed. So what we are getting? R NH2, okay, plus HX. Okay, so here what we got the product. Okay, here we got the amines. Okay, so different nucleophile gives us the different product. Okay, this we have taken what? Monodentate nucleophile. Now let's discuss about what? By taking ambidentate nucleophile. Okay, as I told, ambidentate nucleophile example CN and what? NO2. Okay, so let us take one example RX when react with KCN. Okay, here you have to understand ambident nucleophile means what? There will be two donor side. Okay, which side will react? Where will be the linkage? That you have to understand carefully. So see here very carefully. Okay, so RX X being strong means high electronegative in nature, requires a partial negative charge. R requires a partial positive charge. Okay, now tell me, KCN is an ionic bond, means ionic compound or covalent compound. See, potassium being highly reactive. Potassium is highly reactive and it's smaller in size due to smaller size. Okay, it always form what? Ionic bond. Okay, or the compound is ionic compound. If it is an ionic compound, then K will be positive and negative charge will be on our carbon. Okay, now nitrogen also have lone pair of electron. Now which side will react? Okay, now just focus on the simplest thing. Nitrogen is highly electronegative than carbon. Okay, means nitrogen requires electron. Then why he will donate the electron? He will not donate the electron there. So here who will donate the electron? Means who is having extra electron? Carbon is having extra electron and it will try to donate the electron. So here the linkage will be from carbon. Okay, so now who will attack? I am showing you in another pen. See, CN attacks the alkyl group. Okay, X will be removed. So what will be our product? What will be our product? Just a second. So here our product will be R. Okay, the linkage will be from CN. C. Okay, so R, C, N. R, C, N and then KX. KX. Okay, so the here linkage is from C. So what is its name? Cyanide. Alkyl cyanide we are getting. We are getting alkyl cyanide. Okay, similarly we will take another example. RX. Okay, when react with AgCl. AgCl. Now tell me here which linkage will be from which side? From carbon side or nitrogen side? Here also focus the same thing. First see either it is a what? Ionic compound or covalent compound. What? Ag always forms what? Our covalent compound. Okay, so it is what? Here carbon will having, here carbon is already bonded with what? Ag means it is already busy with our silver. So who is free now? Nitrogen is free. So the attack will be from nitrogen. Means the linkage will be from nitrogen. Attack what? CN will attack. But the linkage will be from what? Nitrogen. So in product what we are getting? Sorry. In product what we are getting? R, N, triple bond C. Okay, and triple. That linkage will be from what? Nitrogen. Okay, so this is what our isocyanide. Okay, isocyanide. And the next one is AgX. Okay, so here what is the hint? If it is what? Ionic compound, means the nucleophile is what? Ionic compound. Ionic compound. Then attack takes place from carbon side. Okay, linkage from carbon atom. Okay, linkage will be from carbon atom. If it is a covalent compound, then linkage will be from what? nitrogen atom. Okay, nitrogen atom. Okay, so here ma'am, you say ma'am this is Cn, that is why you told that carbon atom and nitrogen atom. Then what happens with the NO2? What will be there? There what will happen? Okay, so don't wait, we will be doing that. Okay, Rx when react with let's take nitrogen, that is KNO2. Okay, again it is a which compound? Ionic compound. In Na2, the negative sign was with what? Oxygen. The negative sign was with oxygen. Okay, nitrogen was having lone pair of electron. Okay, so here what will happen as it is a what? Our ionic compound. Okay, so the product will be what? R. Just a second. Product will be R. The linkage will be from oxygen side. O and O. The linkage will be from oxygen side. Okay. And the byproduct will be our what? KX. Okay. Here which one has attack? So this is positive. This is negative. Okay. Who has attack? NO2 has attack to the alkyl group. Here what happens? This is negative. This is positive. This leave. Okay, so this way the reaction is completed. Okay, similarly if I take another example, when Rx react with AgNO2. Now this is what? Covalent bond, means covalent compound. Okay, so covalent compound means what? Oxygen is already involved in forming bond with what? Silver. So here this is the negative, this is the negative part, this is the positive part. Negative part means what? Electron, extra electron. Now the attack will occur to the alkyl group from which atom? Nitrogen atom. The linkage will be from nitrogen atom. Okay, so here X will leave because it is a leaving group, higher electronegative. It pulls all the electron towards itself, acquires partial negative, this partial positive. Okay, now the attack of nucleophile takes place, halogen leave, and the product form, that is R NO2 and AgX. Okay, clear? Here also same. First thing, the thing you have to see, the negative sign, the sign is on what atom. Okay, then you have to see whether it is a ionically bonded compound or covalently bonded compound. If it is ionically bonded compound, then what? Then the negative sign will, the linkage will be from the negative sign which is given to the atom. Okay, now if it is a covalently bonded atom, then nitrogen, the linkage will be from nitrogen. Okay, so clear about this? Okay, these are some examples. Okay, examples how the nucleophilic substitution reaction takes place. Clear? Okay, so next what we are going to discuss? Next we will discuss its mechanism. What is the mechanism? Okay, similarly there are different types of nucleophiles, so there are different types of nucleophilic substitution reaction. Not types, it is of two types. Okay, one is SN1. Okay, one is SN1, another one is SN2. Now what is this one? What is this? So okay, these are nothing but molecularity of a reaction. Molecularity means what? As I told, molecularity means what? We know that number of substrate participated during the reaction, or number of molecules participated in the reaction. If the one number of molecule means one mole of molecule reacted, then it is what? Unimolecular reaction. Okay, then bimolecular means two substrate has participated. Okay, trimolecular means three substrate, means its molecularity is 3. Okay, so on basis there are nucleophilic, two types of nucleophilic substitution reaction, SN1 and SN2, that we will discuss further. Okay, so hope you clear about this. Okay, nucleophilic substitution reaction, nothing but a nucleophile is substituted during a reaction. So what is nucleophile? Just a second. What is nucleophile? Nucleophile is an electron-rich species, means it has extra electron or it has some negative charge on it. Okay, that is called our nucleophile. Okay, so hope you are clear with this. Okay, next we will be discussing SN1 and SN2. Okay, so those who are new to my channel, then subscribe my channel and press the bell icon so that you will be notified for my upcoming videos. Okay, that's all for today. Okay, hope you understood this. If you understood, then like the video, share as much as you can, and subscribe my channel so that you will be notified for my upcoming videos. Okay, so next we will be discussing SN1 and SN2 in detail. So stay tuned and wait for that video. Bye bye, take care.